Hi guys, and welcome to PyMath. In today's video, we're going to be solving this problem from the Kangaroo 2023 grade 9 to 10 question paper. The problem states that how many different ways are there to read the word banana in the following table if we can only cross to a field that shares an edge with the current field and we can use fields several times. So basically, if you don't know what that means, I'll summarize it for you. Basically, how many ways can we spell the word banana using this grid, where you can basically only move to squares which you share an edge with? Let's say if we were here, we can only move here to this square because of this edge, or here to that square because of this edge. So you can only move if you share an edge with that field, and you can use different squares multiple times. So let's say you go from here to here, you can go back there. Okay? So that's basically what the problem states. And this was, again, as I said, on the Kangaroo 2023 grade 9 and 10 contest. So let's get started. Over here I've provided a sample grid for us to get started and the word banana. And that will be useful later. So let's get started. So first, let's look at how we can get these first three letters. B-A-N. As you guys can see, there's only one N on the board, and there are four B's in the four corners. And each of those four B's have two ways of getting to the singular N in the middle. So for example, this B, it can go to the N like this, goes to this A, goes to that, or it can go like this, goes to this A, goes like that. So that B has two possibilities. Similarly, this B can only go to the N either from here to here or from here to here. So that's another two possibilities. And this B can only go to the N like this or like this. And that's another two possibilities. And finally, this B can only go to this N like this or like this. So that's another two possibilities. And really we can just write 8, because there are 8 distinct ways of getting from B to N. So now we're done this part of the word. We're done B-A-N. Now we only need Anna, and we're already at the N. So from the N, there are 4 ways to get to the next A. So from this N, you need another A, right? So, and there are 4 A's surrounding the N, and all 4 of them you can go within one move. So there are 4 ways of going to the next A. You can either go here, 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 or here. So again, there are 4 ways. So there are 8 distinct ways of going to the N in the first place, then 4 distinct ways of going to A's. All right, and then now we're at any A, right? And now we have to go back to N. But from every A, there's only one possible way to go back to N. Like for example, from this A, you can only go back N here. From this A, you can only go back N here. From this A, you can only go back N here. And from this A, you can only go back to N from like that. So for each A, there's only one possible way to go back to N. So we don't really count that when multiplying the amount of permutations, the amount of possibilities. So right now we're at 8 times 4, right? So, and we're back to this N. So we're done 5/6 of the word. All we have to do is get to another A. And from this N, as I said earlier, there are 4 ways of getting to an A. Either here, 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 or here. So all we have to do is multiply this by another 4, and we should have our answer. And when you compute this, this equates to 128. And thus, there are 128 possibilities of to write the word banana if you do exactly what the problem states. And that's the answer. So thank you for watching. And if you have any video ideas, just leave them in the comments, and I'll see you next time.